This is the solution for question 1 of homework 8. In the question we are given a random process x of t, which is Whiteson stationary. The mean of the random process x of t is eta, a constant, and the autocorrelation of x is rx of tau, where tau is t2 minus t1. So we are given a new random process y of t, which is x dash of t, or d by dt of x of t. We are asked to find the mean of y of t and also the expected value of x of t times y of t. So first let's calculate the expected value of y of t. So since y of t is d by dx of x of t, and expected value, when we are taking the expected value, the t is taken as a constant, therefore we can take expected value of d by dt of x of t to be d by dt of expected value of x of t. So x of t is a constant eta, therefore d by dt of eta, which is 0, therefore expected value of y of t is 0. So now let's find the expected value of x of t times y of t. So expected value of x of t times y of t is expected value of x of t times d by dt of x of t. For now let's use this identity. So d by dt of x square of t is 2 times x of t times d by dt of x of t, or 2x of t times x dash of t. So we'll use this identity. So in this place we send the 2 this side and substitute over here. So expected value of x of t times y of t is nothing but expected value of 1 by 2 times d by dt of x square of t. So similar to the previous case, x square of t is the second moment, the expected value. So we take time to be constant, therefore expected value of d by dt of x square of t is the same as d by dt of expected value of x square of t. Now we are given the autocorrelation function rx of t1 t2, which is rx of tau. So if we the second moment, the expected value of x square of t is nothing but rx of 0, which is t1 rx of 0, where t1 is equal to t2. Therefore substituting that, we get 1 by 2 times d by dt of rx of 0. So rx of 0 is also a constant which is independent of time, therefore the d by dt of a constant will be 0, therefore the expected value of x of t times y of t is also 0. Now we are asked whether x of t and y of t are uncorrelated and orthogonal. So two random variables of process x and y are uncorrelated if expected value of xy is expected value of x times expected value of y. So here expected value of x is eta, expected value of y is constant 0, and expected value of xy is also 0. So here we see that expected value of xy is equal to expected value of x times expected value of y. Therefore x and y are uncorrelated, and similarly two random variables x and y are orthogonal if expected value of xy is equal to 0. Here we got expected value of xy to be 0, therefore the two random processes x and y are orthogonal and uncorrelated as well.